Oh, funny seeing you here, Chris Long. Interesting, you're not operating as BC at the moment. Hey, Marway. And we got Dicer Ain. What's that translate to? The something first Turk is my guess. Hey, Lisa. And Joshua. Let's see. Just grabbing my bits and pieces that I need. It's been a long, nasty, horrible week for me here. I had very minimal success. So I'm going to try and do something that I should have success with. It's like regressing back to my childhood level of soldering work. Okay, that's good. Hey, Greg. The backlight drive is gone, and I also separated there's no power coming back through down the flex. Here, look, I'll show you this one. Let's go straight to this. I just realised my microscope's tilted off, which could explain a few focus issues. Alright. I'm the dude who helped on Facebook with the MacBook Pro Retina with no PM bat low. Oh, and how did that go? Did you have any success? That was a while ago now. Okay. Boom. Oh, gee, I love this thing. Yeah, see, what I've done here is, this was the 6S, and I just separated the flex off, and then put voltage into here, and that goes into the backlight panel. I'm using 16 volts and about 4 milliamp, 3 to 4 milliamp, and that works out to be a pretty good balance. You're welcome. I'm glad you got that worked out. It was just a bit of fortunate luck for us that it all worked. Sometimes you make suggestions and it works. A lot of times you make suggestions and nothing works. Chris, I'll show you the state of this board. Let's see. So this is what it's currently like. Let's get a bit of focus. So yeah, the backlight's all been cleared out. I was just fishing around here to make sure nothing had lifted. All this camera stuff's gone. This is the nice side of the board. Let's have a look at the bad side of the board. Alright, here's the bad side of the board. You see, it's had a bit of a dance with death. I've already replaced the Mesa boost and a couple other little bits and pieces in there. A few of these were missing, which were powering it. And chestnut, had to do some fix-ups. Most of these things just fell straight off. It wasn't me ripping them off, they just fell straight off. I will have to put another cap on top of here probably, because its companion actually sits here, but all I've got there is a little nub. That's not enough. This here was a big problem. I changed all these caps because I was getting a boot, but I wasn't getting any screen up. Even with the backlight. So it ended up being this inductor here was completely cactus. It was like about 0.5 K resistance and not much else. Bigger tricky thing to track down was these two resistors were missing. Well, actually they were there, but they weren't any good. And so I was stuck on a 90 milliamp boot. That's all it would do, just sit at 90 milliamp and then bounce back. In pretty good condition actually. I'm not getting any USB lightning communications at this moment. I'm not sure why. It doesn't even come up with ID when I plug it in. Normally Linux will notice that it's a device and say it, even if it hasn't, even if you haven't logged in or anything like that. So I may try to look at TriStar, but anyway. But yeah, this is the real chaos zone. It's for data. So definitely only data, and definitely will not be doing any putting this back into service. So Stockholm was completely trashed as well. That got cleaned up when I was doing other things. Audio, you can see where it all came down through there. But so this is the second day I've been picking away at it. I'm happy now I've got a boot on the screen, but yeah, I'm pretty sure I've got a voltage rail stability issue that's causing it to hang when it goes from the passcode and tries to actually get into the operating system. But at least it's progress. I'm happy with that. I'm not completely fecking it up. Hey Dragon, good to see you. Let's see, switch back over to that. That Acer laptop, right now all my rails are present as they should be according to the schematic, but the CPU gets really hot and it won't recognize anything. Like I'll put a USB stick in there or anything like that, it just doesn't do a thing. So I've already spent quite a lot of time on it. I'm done. Maybe I'll look at it again another day, but for now I am done. So let's see. In terms of customers this week, it's been really, I shouldn't say annoying, but it has been. Got a lot of people turning up and asking me questions and all sorts of things, but nobody's delivering any money to me. And it's like, come on, you bastards. Like I'll be in the middle of working on something and the doorbell will go off and I'll race out there and I find out that no, they just wanted to ask me a question. Or I got quite a few locked out Apple ID phones questions this week. So, my friend has forgotten the passcode. Can you help us unlock it? I'm like, no. But Dragon, if I ever do decide to have another shot at it and put it on stream, I'll put it in the title that it's going to be a continuation from that. The stream has come a long way from the days of old. Pretty happy. I remember before you downloaded this. Yeah, Chris, the funny thing is I actually find liquid damage jobs a lot easier than default jobs. Like, you know, if I had two come in that were backlight failures, I'd probably just coil and driver or something like that. Or just, you know, the thing where you do a full sweep on it. I just couldn't really bring myself to get around and doing that. But if it comes in as a liquid damage job and you've got to recover the data, then I'm all for it. I'm jumping in, no worries. But, for some reason I prefer the data jobs, but not really the data repair jobs. Wrong answers are free, right answers will cost you. Yeah, that's a good one. Yeah. Anyway, so I'm going to build another one of these open broadcaster switcher boards I got here. And the nice thing is this one is I got my blue cherry switch keys. So these ones have the tactile. So here. Yeah, you might not be able to hear that. Anyway, I can feel it. That's the important thing. Backlight easy peasy. It was the 6S backlights. The 6 ones I don't have. TriStars are easy peasy. It's almost like TriStars become too easy. I shouldn't say that. They're probably going to severely underfill them now like they do in the iPads. Anyway, we're going to have a bit of relaxation here and just build ourselves another open broadcaster switcher. Now I've just got to get my bits and pieces. What do I need? I need controller. I've got my crystal, couple of caps. I need my USB port. Gotta go into the other workshop. It's not really a workshop, it's more of a cesspit where things get shoved when I haven't got any room for it anywhere else. Oops, ow. Okay, that almost hurt. Almost became a Principal Skinner victim then. Get trapped under the pile of trash. Oh, come on. Every time I come in here to... Yeah, got him. Every time I come in here to get these USB sockets, I forget to bring them back out. And now I've got them. So now they're going to be placed randomly inside this workshop until such time that I've forgotten that they're in here and I spend 3 hours looking for them again. Okay, that's that. Right, microcontroller is next. And where did I put those? Being organised is not my thing. There we go. These are just ones that I've got a cough. Hang on. Ah, the mute button saved me. Ah, that was awesome. I just want a Mega 48 that can do 20 megahertz. Oh, bingo, first one. Oh, Mica stream, Mica only stream. Oh, what's it gonna drop? Drop test a MacBook the other day? Crikey. Yeah, like I said, I've been fighting with a week of nothing's going quite right and not enough money flowing in. I think it's the not enough money flowing in that really pains me more than anything else. Alright. Seems my camera's a little out of kilter, or is it just my head? I think it's my head. So that looks level to me. It's almost level to you guys. Stop messing with it, Paul. Keep messing with it, and something will go wrong. Alright. I think you all can hear the dogs going off. Man, you are one ugly looking Mega 48. I hope you do your job right. This one is probably already... Oh, I can't even turn it around. This one has probably already been flashed to run at 12, run off a crystal. Well, I guess we'll find out. Not that it matters, because I flashed it anyway. Alright, let's get this underway and I'll just pick up the bits as I need them. Yeah, we don't need that. I need to get a sturdier mount for this camera. It's going to be interesting to see how these legs take to solder because, well, they're a little bit gnarly. Yeah, they did alright. I think. We'll find out when we try to flash it. Like I said, this is a really shonky Mega 48. Under normal circumstances, this probably would have gone in the bin. More flux. I should probably put all these chips when I pull them off into the ultrasonic cleaner. Pin through. I hate pin through. I was very glad when surface mount became as popular as it did. Pin through and I never got along. I used to hate doing things like when you try to pull out 40 pin dip chips, even with a proper pulling device, and the number of times you'd either slip and get pins through your fingertips. So yeah, it's just yuck. Okay, those pins there are really going to need some help. That's better. You're being reluctant still. Oh well. Okay, we need a resonator. Hey Mark, welcome. Oh, g'day Wayne, didn't see you sneak in there. Get out. For God's sake. Come back here. What is it? I'm gonna blow away. Come on, beep. I actually have to say, this is probably one of the simplest USB contraptions I've got, so far as all the support logic and glue logic, etc. Normally a lot of my projects have got a heck of a lot more stuff going on. So you guys are the 68s. Get all the tweezers. Just leave a nice greasy snot trail along there. Chip fingers, yeah, that's a good term for it. Where's my second one? Come on. There we go. Cheap desoldering station. Oh, you mean like a pin through one? Yeah. Those combination pumps or something. There we go, remember we've got to get our non-polarized resistors the right way around, or else it runs backwards. Now I've got to go and... So what diode should I use? I could use more MILF diodes. What have we got? I should take a vote. Aha. We'll do it differently this time. We're going to have some SOD diodes. I do believe they were the ones that I originally designed it for anyway. I don't doubt I'm going to have someone complaining that I didn't use the MILF diodes. I think I'm going to have to upgrade my project soon and start using 0402, 0201 type stuff more frequently. It just seems so... It's like playing with Duplo blocks now. Stuff this size. It's just so big. Can you imagine having a 1206 capacitor on an iPhone? I think the biggest you really see on there may be an 805. Bum 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 bum. Now we're going to put the LED resistors on. Way too much. Way too much. It's actually pretty damn hard not to put too much solder on these pads. So you barely touch it and they just straight away. That's better. What is it? Yeah, an open broadcaster. Weighing it so I can do things like, okay, this is it. Now I've got 4 different scenes set up on here, so I can just press a button, and I need to be. The only trouble I've got is I need to be actually in. So switch, 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 back to the start. So, and then I can mute. And unmute, and I haven't really sorted out the stop-start one yet. I mean, it's not a technical problem. It's just Paul is busy doing other things, and I would like to still somehow provide a confirmation thing. So I'm trying to contemplate on a 2-stage switch. Oh no, it's upside down. Cannot have our numbers upside down. There we go. But now we're crooked. And we're off center. Great. Oh well. These are just 220 ohm resistors for the LEDs. It's certainly not critical. It's like, pick a number between 150 and 1000. And you can say that that is the value you want. I mean, it does make a difference in terms of how much current the resistor will, the LED will draw. But with most of these LEDs, they're good for anything between about 3 milliamp up to 30 milliamp. So you got a factor of 10 to work in there. I prefer to go for the least amount of current required to obtain a visible daylight result in this case. And I find 220 is pretty good for that. For purely pilot type LEDs on say 5 volts, I usually end up with about 1k resistors. So there's enough light there if you're looking at it and you want to... It also depends on the efficiency of the LED. I mean, I've got some little 1206 size LEDs, green ones, and they are just blinding at about 20 milliamp. So much so that I use them as a remote beacon for lost model aircraft. That took too long. Oh, it's because it's a ground plane, of course. I probably could have put 0402s on here, and that would have meant they'd sit a bit flatter, which means the cherry switches won't pop up too much. But I've barely noticed it anyway, as it is. The resistance will fall out. Oh yeah, Greg, that camera port. It was good that he went back and just, yeah, got it fixed up. Because I know, I mean, sometimes when that sort of thing happens, you really do just want to throw the towel in. I mean, I must have done the chestnut on that 6S, I think it was about 4 times. It just wasn't sitting right, and yeah, normally when you put the BGAs down, you can see when they settle in and you feel confident about them, or at least, you know, pretty good about them. But every single time it was just, no, you're not right, you're not right. I was really starting to get concerned, because I was thinking how much further I got before the pads decide that they don't want to play ball anymore. Well, that's a little shonky. It'll work. Alright, let's get to putting the switches in. Now I bought myself oh yeah, that's right. I bought myself a dozen of them, which means I can do 2 of these boards, but I'll probably do the second one when I get the next set of boards. Let's turn that off for the moment. You're off. Yeah, that's right, Greg. Yeah, with the microphone being out of place. So I guess it was... maybe I'm a bit superstitious or something like that, but the number of times I've found if you... I found when something goes wrong on the reassembly and you're like, oh, you know, I really should put that back together. And you find out that it was a good thing that you did, because you sort of go, oops, missed that. Let's see, what do I need? I need my drill bit. Bits and blades. If you haven't got them already, do consider getting something like these set of drills. They're on 1/8 shank, 2.35, take your choice. And then these here are what we call a pin vise. It just sort of holds the drill bits. Not much use for doing big jobs, but for small, delicate hand turning stuff, that's good. So we went up to 1.8 last time, I believe. Gonna need the microscope again for this. This is one of the few times I sort of think, yeah, a 0.5 Barlow probably wouldn't hurt. But I'm not going to change my Barlow lens just for this. Looks like I need to tighten up my grip a little bit there. Most of the time I am very happy with my 0.7 Barlow. 0.5 was just too far away. I mean, I know some people like it and that's great, but for me 0.7 was the winner. And 1 by I actually did like just no Barlow at all, but I gotta admit I did find it a little harder than I wanted for handling the tools. Maybe if I get some special bent nozzles and bent tips. Okay, now the reason why I'm drilling these out is because those viewers saw the previous stream, the board layout that was supplied by a Spark Fund for these things, or I should say the library part, it was wrong. It was about 0.05 inches, what is that, 50 thou? Yeah, it was 50 thou out, so I'm compensating by drilling quite a bit more than 50 thou. But you have to remember that I'm only getting to move back half of what the drill bit is. So this drill bit's 1.8, so it's let's call it 70 thou, so I'm only getting back 35 thou, so I've still got 15 thou to cram under here. Alright. Fortunately it doesn't affect the switch. Now I'm still running into issues with Bluetooth on these. It's not actually a fault with the software or anything, it's something about the back end. It just loses synchronization or something, and then that's the end of it. The 0.7 I've got has a working distance of, I can't read right now because it's behind the ring light. I don't know if it's power management laser, because I think it's another process running in background somewhere. Because when I'm not running a bunch of other things, it goes on indefinitely, it's perfectly fine. So it's something interfering. It's something that talks or tries to talk to the Bluetooth, and then once that happens, my program loses the capture, so to speak. And once it loses the capture, it can't regain it again without going through the initialization process. So what I probably should do is I should sort of put a timeout so that if I don't hear from the meter within a certain period of time, then reset the whole thing and start again. Ideally though, I'd like to step away from relying on the output of the command line program as I am at the moment, and just do it natively through a library. But to be fair, this works now, so in most cases, with the odd glitch. But like I said, I don't think the glitch is with my software, but I probably should amend the software a little bit to compensate for the issue. Yeah, it's pretty typical, compensating for faults that aren't yours. Okay, that's our green ones. We need a yellow and a red. I am working on a new design as well for the broadcaster thing, and if I can work out how to do it in software, I am trying to make a more complete open broadcaster console. We'll have a screen, like it'll be like this, but then I'll have a VU meter there for the audio output, and then a screen here just giving you the details of like drop frames, things like that. Now I realize you could just turn around to your computer and have a look, but it's not always convenient to do that. You don't always want to have to bring Open Broadcaster back up. But I have to see if I can do the communications the way I want. And if I can, then I have to write a plug-in for Open Broadcaster. So it's a bit of work, and I can pretty much guarantee that I'll make about $0 out of it. But you don't do these things for the money. And I probably should, but I don't. I mean, geez, I spent, what was it? A year, 6 months to a year doing open board view, or amending it rather. Now, what do we have? Microscope time? Yep. Star World, as I mentioned, I'm pretty sure it's an issue with the nature of Bluetooth LE. Because with Bluetooth LE, at least the way this one works, there's no binding involved, so you don't claim exclusivity indefinitely. It's really just a grab thing, so if someone else comes along and grabs the handle, then you lose it. So, I mean, it makes a very simple protocol, but it does obviously make it prone to this sort of problem. Yeah, I'll get it worked out. It's not a process starvation contention issue as such. It's more of a token theft type thing. The device runs through the GATT system, which is the generic attribute table system. I think table is it? No, whatever. And yeah, so there's no real authentication, blah 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 blah. There's no authentication or anything like that. It's just first come, first served. And it would seem that the command line program that I'm getting the output from doesn't really handle someone else taking that from it. Maybe there's a parameter I can set in the command line. Anyway, the source code's on the internet, so feel free to amend it. I wonder how long these nippers are going to last around here. They're good, they're really good nippers, but the trouble is I have a bad habit of using the wrong tool for the wrong job at times. What does that mean? It's I suppose it's the wrong tool for the right job. I noticed the 3mm LEDs don't really sit in the recesses properly. It's almost like you got to carve off that chamfer. Oh crap, I probably just bent that. Either that or you got to use 2mm LEDs. Anyway, it doesn't bother me. Where'd my solder go? Probably should use some thicker stuff for this. Alright, I'll see you later, Marway. Thank you for dropping in. Appreciate it as always. Oh yeah, that's right. You gotta wait for the soldering iron to heat up, Paul. At least my $200 fume extractor works well. And that's on low velocity at the moment. You suck those fumes up good and proper, because I don't want my lungs doing it. Hey Tony, yeah, it's all going good. I'm just making another one. Yeah, this one looks all pretty and everything, but sure hope it works. Look up. Let's see if I can catch up on chat here. Scissors. I don't think I'll be using scissors. The fume extractor is a fair bit louder than what it comes across in the stream recordings, because I've gone back and had a listen. So I do want to still put a muffler on it, and I can, for about $100, I can get it's basically just a carbon canister, and it'll have the dual effect of attenuating the noise a bit, as well as filtering the air that bit more too. Yeah, let's see what I'm after. I need to program this now. Oh, I did find myself a 7-port hub for my USB. Though since we're not going to be programming things as such, I won't have to. I also built myself another AVR programmer. So I got a bad habit of losing them, and so I figured if I build another one, that's probably another one that's going to get lost, but oh well. Alright, now to do this I'm going to have to steal away, because I've only got the one cable, steal away my open broadcaster. What the? Oops. Looks like my HDMI cable is a little bit iffy today. Yeah. Can we make it a little closer? Of course we can. Okay, that's good. Get dragged off the... Okay, that's good. Should be able to just build that. Okay, good. I just wanted to check that I actually had the make fuse option. Okay, so here we go. Oh wow, it actually did work. Alright, make flash. That's good. Let's see if this one works. We don't need the X-term anymore. Okay. Yeah, I've got a I got a LED in backwards. Whoops. Mute. Yep. Okay, that's working. Except for that one LED, I'll have to redo that. A zero effect. It's a, funnily enough, a cherry blue switch keyboard. It's what is it? It's over here. It's one of these things. It's a KD 104. What is it? IKBC KD 104. It's to replace my IBM M keyboard, which unfortunately has gotten just a little bit too ratty. I have to get this out. I should use that board to switch scenes while it's being operated on. Alright, so there you can see there, see it's backwards. It's supposed to be the flat side is your cathode, and I've got it on the anode. That was a really amateur mistake to make. Oh well, these things happen. Now, since it's a junky board, we're going to use junky wick for it, which means I'm going to be using Chris Long's tech spray. Oh, look at that, Chris. Your tech spray actually worked there. Personally, I'm more a fan of Goot for general daily stuff. But I gotta admit, I do find Chris Long's the tech spray good for a lot of the iPhone work because of the finer pitch of the weave. Don't you dare rip. This is what I do hate about Wick. You always get that last little goddamn bit that just doesn't want to let go. Yep, see? Just hanging on there. And then you can do that and you damage your tips. Come on. So you have a choice. Damage tips or... Okay, you're free even though you pulled away part of the veer. Sure hope that was the right one I was yanking. I think that was my fingernail breaking. The heat and pull is nice if you can actually... There we go, that's what I wanted. Come on. It's a little hard on these ones to do. There's not a lot of room. Commencing to rage and... Alright. I was just gonna have to put solder back on them, and funnily enough, and then wiggle them out. So this is why I hate pin through. Because it's a colossal pain in the ass to get things out. You out yet? No, you're getting there. Oh yeah, wait, you are. Yes. Come on. There we go. Ah, that that mute button really is handy. Yeah, at least with surface mount, you just take it off. God, what a wreck. Those holes are well and truly ruined. And then when you're putting it back in, you got to do this sort of stupid thing. So yeah, I do not like pin through parts. Anyone get the 3D effect then of that leg come flying in your face? It'd be funny if I actually got that backwards again. Okay, thankfully it does. It does not look like I have. Okay. Hey, it's correct now. Excellent. Alright, well, that's done. I'll give it a wash down. Because the solder that, this Kester solder that I've got, it's actually an active rosin flux, so it does tend to, if you leave it there, it probably will have some interesting effects on the board over time. I could put in the ultrasonic, but the ultrasonic's probably going to make it worse than what it already is. I need to clean it out. Toothbrush. Look at that, the cheap, nasty, pulled AT Mega 48 still managed to do its job. Wayne, looks like you lost that $10 bet, buddy. I got it back right. Fun hanging shit on the... Oh, yes, that's right. They had the New Zealand around there. Let's clip the legs off those. That leg just went flying somewhere. Good reason to wear eyewear. Okay. Well, I think I'll make this one my primary switcher for my daily use, and the other one I'll probably use as prototyping, or it'll probably sit and rot somewhere. This one looks pretty now. Yeah. Nice to have a bit more of success at the end of the day. Let's see. No, rubbish bin's right there. Let's see. Are those switches sealed against dust and water? No, they're not. No. But they are mechanical switches, they're not membranes. Should remind ourselves what capacitors short out all the time. Come on. It's not our fault that the capacitors that they use are, well, all SMD. How many hours have you invested in the OBS switcher? Probably, I think it was about 2 hours to dig up the reference design and then make up my own, and then send that off to get turned into circuit boards. So, and then when that came back and there was a few little glitches there, yeah, so let's say a day of overall work. The coding was probably the more problematic part. And I shouldn't even say problematic, it was just a case of finding out the right way to do these things. But the only thing I don't like about the circuit board services that I use is that, like, I order, generally I only need maybe 2, maybe 3 boards, but then you can only order a minimum of 10, and half the time you end up 12 even. So I don't know what, this is my second one. I think I've even got 12 in here, so that's 8, 9, yeah, with 11 boards here. Now all of these are really basically never going to be used again, so, because that's the first pass prototype. The next one I'm doing has the better seating for the switches, and a couple of other little features I'll put onto it, which hopefully I can get to work. And these just sit around and do nothing. I do keep them though, because I don't know, maybe in the future I'll have another project that I need to do a USB type interface that has switches. Yeah, it could be useful there, and I can maybe use it as a development platform for something else. But overall, 99% of the time these boards just sit around and rot. I know, because in the last 10 years or so I have got a huge collection of boards that just nothing happens. So, like, I mean, these little things, these are so I can program a particular type of microcontroller, a 6-legged microcontroller, using that programmer I had before. And yeah, it's just, you get this collection of boards upon boards. I hate to think what actually happens in places such as well, Apple for instance. They must go through a couple of revisions a day, I wouldn't be surprised, when they're prototyping things. And so they'll etch the board, build the board, test the board, modify the board, and throw the other ones out. What have I got here? Oh, Tony, thanks for that. Yeah, I do find more than anything I tend to be a bit of a tool maker, jig maker, things like that. I do my work, but 90% of the time I'm always sitting here thinking, how can I make this a bit easier for me, or what contraption can I come up with, what piece of software can I write. I mean, Open Board View, modifying that was the same sort of thing. I wanted to be able to do it on Linux. Unfortunately, people like Pernov and whatnot already had just started porting it, but then there was a million things in there that I didn't like, and so I just got suckered in and started writing more and more code for it, until the point where I felt, okay, I can use this on a daily basis and not be complaining too much, and that's pretty much where I stepped away from it. But I'll probably get back into it at some point in the future. Could I get a couple of the circuit diagram parts? List Paul, what postage? Oh, Leslie, yeah, look, I'll just, you can just message me and I'll send over a few of the boards. But the thing is, you probably really want to wait for the second revision, the one that has the fixes, so that you don't have to drill through your switches, and that the switches don't sit up slightly high. You shouldn't have any trouble getting a hold of the Mega 48 either. They're a pretty common chip. You can use a Mega 88 or anything you can get. A free Huggus? No, I don't think so. Why don't you make your own? Good reason for that. It's boring. It's truly, utterly, mind-numbingly boring. Manufacturing, the fun part is the prototyping, the testing, all that sort of stuff. That's when it's interesting. Then when you get into the manufacturing cycle of it, you want to gouge your eyes out. I did it for a long enough time. I don't want to do it again. If I'm going to get them, sorry, hopefully I'm not showing any plumber's crack. Okay, what we have here is this is a box of perhaps one of my most successful products. Interestingly, it wasn't one that I thought was going to be successful, but it was. Let's see. Now I've still got some pre-built here. Okay. In the model aircraft community, there is a particular type of aircraft that we call a discus launch glider, or a DLG. And these gliders, obviously they don't have a motor because they're a glider, and you launch them by grabbing them by the wingtip and then doing a spin, and then you launch it. You get about 150 foot launch out of that, which means you can fly for about a minute and a half, typically, if you're really good. If you can catch a thermal updraft of air, you can be up there as long as your skill lets you. Anyway, those things, the radio control in them obviously needs power, and we used 2-cell lithium packs, which is 8.4 volts full charge, and that's too much for most of the servos and receivers at that time. They've changed that a bit lately. They've gotten better with high voltage stuff. Anyway, so the request was someone needs to make a regulator that will take this 2-cell pack down to 5 volts, and also it'd be nice if we could have a low voltage alarm, so when you say get to usually around about 3.7 volt per cell is time you really need to put them back on the charge. And so people want an alarm for that. So anyways, this is what I came up with. This is about the 14th revision of it. It's a fairly small little thing. It's the regulator is this large brick here. It's just a standard linear regulator. It's going to be better if I do this under the microscope. Makes more sense that way. And microscope time. And yeah, I can hear the dogs. Holy crap, this is a dreadful solder job. I wonder it's still sitting in the... This has probably been sitting here for 5 years now. Anyway, this is all hand soldered, unfortunately, because it would have been one of the ones that I did after I stopped the production line, where I was doing everything in a bit of an assembly process. Anyway, so we've got this is a six-legged microcontroller. It's also an Atmel AVR. There's a bit of trickery in programming it, but it's all good. So you get your 1 amp regulator, that takes your 7.2 volts coming in, drops it down to, in this case I make it about 5.5 volts. Now there's 2 reasons why we do that. With linear regulators, any voltage you drop has to come off as heat. So the less voltage you drop, the less heat you produce, which means the more current you can draw without cooking the regulator, or at least without letting it go into shutdown mode. The other reason is that the extra voltage is also good over thin wires, so when you're drawing more current you've got a bit more overhead so that your receiver and servos don't brown out. Let's see, so what else? So yeah, regulator, the voltage setting. This here is a speaker assembly. Picking a suitable speaker assembly was something that took quite a while. This here will produce about 92 decibel. I deliberately overdrive it beyond its spec, but because it's so intermittent and whatnot, I can do that without really worrying about it. This is a little MOSFET that turns the speaker on and off. And this is one of the LEDs that are quite bright. This is a 1206. I'm not going to turn it on or plug it in with the microscope here. I'll blind myself quite literally. Anyway, so all up, a bit of decoupling caps. Hey, look, a bit of solder ball. I wonder if that's causing a short. No, it's not really. Oh, and a great big decoupling cap too. What was I going to say? Yeah, all up, I managed to get these things down to around about, I think it was $3.50 or $2.97 for the bill of materials per unit in 100 lots, and I would sell them for around about $39. So it was a really good markup, but even though they only took around about 10 minutes by hand to do, you after you've done the first 10 for the day, even though you're thinking, okay, I just made $300, you really just get sick of it so quick because it's like the same thing day in, day out. The reason why this didn't use a buck converter is because the RF issues, because remember we're dealing with a radio control model and they were using, some of them use 36, some use 72 megahertz, some use 2.4 gigahertz, and having that RF noise coming off, and because we need to be very small and very light, you can't shield it, so it was just off the table. Plus, it was actually much bigger doing it with a switch mode controller. See if I can find the... Yeah, I did do one, because I wanted to see what it'd be like. I wanted to see if it was doable. No, I can't find it. But it ended up being about twice the size, and the gains weren't really that great. Particularly because a lot of the time these planes, when they're flying, they're not doing a lot, so they're only just sipping at the current. And with switch mode controllers, when you drop below a certain current draw, they actually become less efficient than linear regulators. So overall, within the full flight pattern, you find that the linear regulator ends up being pretty much the same. So there was no real gains. It was more expensive, more complicated, more RF noise, and bigger. So we went just stuck with the linear. It was fine. You get upset with prettiness. Function is the thing that really matters. Well, I like things to look decent when I'm selling them too. You may have speaker driver excursion issues even if the long-term power is within the rating. Yeah, well, the beeping thing on this, it would be a duty cycle overall within the flight pattern, perhaps 0.01%. It only ever goes off when the alarm's going, so yeah. Arduino, I have never used Arduino. I just code directly in C. I've seen Arduino, and for the most part, at least when it started being developed, it was predominantly just a set of macros that translated into C. At the end of the day, I just write in C and it's easy enough. It's quick as far as I'm concerned. There are some conveniences that the Arduino layer provides, like portability now between different microcontroller sets, but if you're coding within the AVR family, then it's not a problem at all. That was the only thing with this, is those 6-legged controllers, they've only got 512 bytes of code space in them, and they don't have a stack like the bigger ones, so everything has to be done in assembly, which is a bit of a different way of doing it. It's like going back to the old basic days, because you can't push anything to the stack, so to speak, to go into a routine and then pop back. You have to, it's all just jumps and go-tos. What have we got for time here? 2:46. Probably time for me to knock off. Alright, well, that's it. We built another open broadcast scene switcher, and I have to think, yeah, I'll probably keep the other one as a prototype. I'll send off the second versions probably next week sometime, and then when they come back, then I'll see what we can do about sending out a few copies to people, and hopefully everyone else can have a shot at it. The source code and the boards and things like that, they'll be uploaded as open source hardware, software for everybody. I'm not trying to capitalize on this, because as it is, someone else created the template that I used from this anyway. So alright, so that's it. I'm out. Anyway, I'll catch us all later, and until next time, you'll take care.